Hello all, welcome back to our discussion of circles. So today we are going to talk about the angles that are in circles. I know what you're thinking. Angles are pointy, circles are circly. There's no angles in there, right? We're used to thinking about shapes like triangles that have points, right? So they have angles at the ends. Or something like a square, so it has corners and there's angles at the corners. Circles aren't like that, right? They're nice and smooth around the outside, so I don't really see any angles, right? And there aren't any yet, but there's lots of angles that can show up in circles, and depending on the type of angle that we have, we do see some special relationships. Okay, so I want to talk to you today about one particular kind of angle and that we see in circles and the kind of stuff that comes from those kinds of angles. Right? So what happens when we have a circle? And you see this circle here, we have circle S, it has a diameter across it, right? This chord that goes right through the center. If I come in here and I add in a radius, notice what I've done. I've created angles. There's an angle here, there's an angle here, and there's a big angle down here, straight angle, a 180 degree angle. And we know that all the way around a circle is 360 degrees. Okay? So if I look at that circle, I can figure out those three angles. This one, and this big one, hey, I made a smiley face, must add up to 360 degrees. I know this one, since it's a straight line, has to be 180, and I know these two have to add to 180. So even though I have this round shape, I have lines coming out of the middle. I have radiuses, radii coming out of the middle. It's creating angles. Right? Now, I could add more lines and create even more angles, right? So if I come in here and I draw another radius, look what I've done. Instead of only having two angles up here, now I have three. And I have this big one down here. That's a winky face. I could also come in and instead of drawing a radius, I could draw a chord. And if you notice, when I draw that chord in, I start creating more angles and kind of funkier kinds, right? So I still have this angle here and this little angle here and then this little angle here, but look what I've done. I've now created some angles up here. There's an angle here. It's different than this one in the middle. These are kind of all coming out of the center, right? This one's sitting up on the edge of the circle, but it's an angle nonetheless. And if I put more chords in, I put another chord, look at this. I get another angle down here. 1, 2, 3, 4, 5. I also get some angles here where these two cross. I got some vertical angles. Anytime you see two straight lines coming together at a vertex, you've got an angle. Now, up here where this hits the curve of the circle, we wouldn't call that an angle because this is a curved line, right? But anywhere that you see two straight lines coming together, you have an angle. And today, I want to talk to you about these angles that come out of the middle of the circle. Any angle that comes out of the center of a circle is going to be special to us, and it's got a name. All right, so let's take a look. Okay. Okay, so those angles that come out of the center of the circle, come out of the middle of the circle, have a name. They're called central angles. So let's write down a definition for central angles and then we'll talk a little bit more. Okay, so a central angle is an angle with its vertex at the center and the two sides are just two radii, right? So if I go to the center of a circle and I draw two radius, I'm going to draw one to over here and one to up here. I create a little angle right there. That angle is called a central angle because it's an angle that comes out of the center of the circle. I'm going to come over here to this big, I wonder if I can move this. Come with me. Okay. Whoa, sorry. Come in here and draw a radius. I'm going to draw another one over here, like way over here. Okay. This angle right here is a central angle. Okay, now, why do I care about a central angle? Okay, well, what a central angle does is it creates what we call an arc. Okay, so definition of an arc. It's a portion of the circumference. Okay, so let's think about what that means. I lost my central angle up here. Here's my central angle, right? So if I come down here and I draw my central angle again, where these hit the circle here and here, this piece right here of the circumference, that little curve right there, is what we call an arc. Okay, so an arc, if you took it out, it would just look like this, right? Well, not exactly like that. You'd be a better artist than me, right? But you could kind of like imagine that this is a pizza or a piece of pie or something, right? And we cut a piece out. This edge right here isn't going to be straight, right? It's a little bit curved. That's an arc. We call it an arc. Okay? Now, depending on how big the arc is, we give it a name. Now, listen, how am I going to measure an arc? Interesting. We measure it the same way that we measure the angle. So let's say this angle is 60 degrees. If that central angle is 60 degrees, we say this is a 60-degree arc. If this angle over here, if this central angle over here, let's say this is 100 degrees, then that arc is a 100-degree arc, the arc that it created. So if that's 100 degrees, then you go to those little endpoints and follow around this arc right here. Oh my goodness gracious. That's a 100-degree arc. Now, that arc right there is what we call a minor arc. The reason we call it a minor arc is because technically, when I drew that central angle and put those 2 points on the outside of the circle, technically, I created 2 arcs, didn't I? Now, you might be saying, lady, like, don't get crazy, right? Most people, when they look at this, I'm going to really try to draw that neater. Let's see if I can do better. If you put the 2 points on the curve, right, you're probably going to connect them using the shortest path possible. I don't know if any of you thought this in your head. You may have gone, well, wait a minute, why are you connecting them this way? Why don't you go all the way around the long way? Well, I could, right? We call the minor arc the one that's the short distance between the 2 points, right? So if I put a point right here and a point right here, if I said to you, okay, I'm at point A and I need to get to point B, most people are going to say, oh, okay, well, go like this, go from A to B, the short way, right? You would be going along what's called the minor arc. But some people would say, you know what, if she wants to go from A to B, let's send her the long way, right? You might go, you know what, go all the way around, lady. Go this way, go the long way. It's still an arc. That arc we call the major arc. Minor meaning small, major meaning big. Okay, now think about this. If this is 100 degrees, if this is 100 in here, I know a full circle is 360. That means this arc out here, this big one here, must be 260 degrees because there's 360 in a whole circle. So if this angle right here, this central angle is 100, then this arc is 100 degrees. That leaves 260 over here, which means this arc is 260 degrees. So here's how we name arcs. Okay. If your arc is less than 180 degrees, it's the short distance between the 2 endpoints. We call it the minor arc. We call it a minor arc. Minor meaning it's small, right? It's less than 180 degrees. It's kind of like acute and obtuse for angles, except the boundary is 180, right? So if it's smaller than 180, we call it a minor arc. And notice the notation here for arcs. If I write whoops, sorry. If I write AB and I put that over it, that's a segment, right? 2 endpoints. If I write AB and I put lines on there, that's a line that goes on forever and ever and ever. If I write AB and I put a curve over it, that's arc AB. So the notation is saying, look, go from A to B, but the path you're going to take isn't a straight line. It's a curve. It's an arc. So that's read arc AB. Now, if I have a minor arc, I name it with 2 points. So that arc, that 100-degree arc that I just drew up here, is arc AB. So we could say that arc AB is 100 degrees. If I want you to go the long way, what I have to do is add another point to the name. Okay? So if I want you to go the long way, if I want you to take the major arc from A to B, what I have to do is if I have to have another point over here somewhere. I'm going to add a point and call it point C, so that instead of saying arc AB, I'm going to name it with 3 points. And the reason I'm going to name it with 3 points is I need to let you know you're going to go from A to B, but I need you to go through point C on your way. So if you want me to take the long way, it's going to be arc ACB. We're going to say go from A to B, just like you did up here, but don't take the short route. Go through C first. Anytime you see an arc with 2 letters, you know that's the short way from one end to the other. If you see an arc with 3 letters, you're taking the long way. Right? Minor arc is the small one. Major arc is the big one. Okay? So any arc that's shorter from the short path from A to B, right? This is a minor arc here. If I want you to take the long way, it's AB, I got to put a point down here. So you know, got to go through C. You got to make a stop, right? Got to take a transfer at C. So short one is a direct route from A to B, fastest way you can get there. Major arc, go to C, and then keep on trucking to B. You got a little transfer here. You got a little layover if you're riding an airplane. Right? So that's the difference between a major and a minor. And again, there's a difference in how big they are. There's also a difference in how we name them. A major arc, a longer arc, is going to have a 3-letter name. All right. Last but not least is this fancy word semicircle, which I have no doubt you've seen before. And all a semicircle is an arc, right? So look, we know a semicircle is half a circle, right? Now, there's major arcs that are bigger than 180. There's minor arcs that are smaller than 180. And then there's this guy. He's exactly 180. A semicircle is exactly half of a circle, so it's exactly half of the circumference. So this right here is a semicircle. From there to there. Now, should I name it with 2 points or 3? Doesn't matter. There is no long way or no short way, right? If you're going from A to B, if I say to you arc AB and you go this way, it's the same exact distance as if you go this way. It's exactly half. So for a semicircle, it doesn't matter. We can just name it like a minor arc because it's not going to matter, right? Now technically we don't call it a minor arc, right? Because the rule is minor is less than 180, major is greater than 180. So if you have exactly 180, that's a semicircle. It's kind of a line. It's like acute angle, less than 90, obtuse angle, greater than 90, and then right angle, the guy right in the middle, right? A right angle isn't acute, it's not obtuse. It's a perfect 90-degree angle, it's a right angle. Same thing here. A semicircle isn't a minor arc, it's not a major arc. It's a perfect in between. It's the line in between. Okay, so again, more vocabulary today. I doubt that you've talked about arcs before. And some key things. Again, the difference between major and minor and how we talk about their notation, and the really, really important idea, because this is where our numbers and our equations and all that good stuff is going to come in, that however big this angle is, that's also how we would measure the arc. And that's going to become important to us in trying to figure out the length of this thing, right? Eventually we're going to say, well, how long is this line? If this was like a walking track, how long would I walk if I walked from A to B? That's going to be a trickier question to answer because it's not a straight line. Okay, let's try some. Right, you're going to recognize this diagram, right? Okay, so in this picture, I would like you to take a moment and answer the questions about where you see a central angle, where you see a minor arc, where you see a major arc, and where you see a semicircle. Okay, go ahead. We'll go over it in a moment. All right, so when you're looking for a central angle, you got to go to the center of the circle, right? It is a central, it is a central angle, so we're going to the center of the circle. So any angle that comes out of the center of the circle, I can call a central angle. You better be able to name it with S as the vertex. There's a bunch here, right? I could name this one as a central angle. That would be angle CSJ. That's a central angle. Right? I could name this one. That would be JSN. There's this guy. He's a central angle. That would be NSV. I also could name this big 180 degree straight angle over here. That would be angle CSV. Those are all central angles because they all have their vertex at the center of the circle. Now, I also could get crazy and kind of combine them, right? So I could say, well, what if I put these two together? That would be this big angle right here. Okay, fine. That's angle JSV. I could do the same thing with like these two, put them together, right? That would be angle CSN. I could get crazy and go like, whoa, around like this. That would be huge. Right? There's lots of different ways I could find central angles here, but the key is, notice, all of these angles have their vertex in the middle of the circle at that point S. So anytime you can name a central angle, you should be able to name an arc that goes with it, right? So for example, CSJ, that's the worst color I've ever picked. How about green? Okay, CSJ. So angle CSJ has endpoint C on the circle and J on the circle. There's an arc, look. That arc is definitely less than 180 degrees, so I'm going to list that as a minor arc. CJ arc. Okay. What were other, let's see, we did this one, right? JSN. So JSN. There's an arc from J to N, right? JN. Also a minor arc. You can see it's less than 180. Okay. How about NSV? NSV. There's the arc that goes from N to V. That's also a minor arc. So pretty much any of these, even, let's see, JSV. So I'm putting arc JN and NV together. So one big arc, JV. Also minor. Most of these ones up here, even if I put CJ and JN together and go, oh, CN, that's still less than 180 degrees. It's big, but it's not bigger than 180. Okay. If I want to get bigger than 180, I've got to go more than halfway around the circle, right? So halfway around the circle, let me clean up my picture a little bit here. Okay, halfway around the circle would be a diameter, right? So if I went from C across to V, so arc CV is halfway around, right? If I go from C around this way, that's a semicircle exactly, right? So arc CV is a semicircle. So if I want a major arc, I gotta go further than that. So what if I went C to V and then kept going up to N? So CV, keep going to N. That's a major arc, right? C to V to N. I could say, you know what? Keep going even further. Go from C to V and then go all the way to J, right? Keep going. That's a major arc. So look, I could call that CVJ. Go from C to V and keep going to J. Or I could leave V out of it and use the N, right? I could say go from C to N to J. It's the same arc. I could use this little guy down here too, right? I could say go from C to L to J. That's telling you go around this way, right? Because if I just say CJ, you're going to go that way. You're going to take the short way, right? If I want you to take the long way, I've got to use one of these points in between. I say, okay, go from C to J, but if I put an L, a V, or an N in the middle, that's letting you know you got to go around the long way, right? So if I just say CJ, that's the short one. If you don't want the short one, you're still going to have your C and your J, but you have to have a point in the middle to let them know. Don't go straight from C to J. Make a stop first. Go to C, then L, then J. Or go to C, then V, then J. Or go to C, then N, then J. Any of those letters, L, V, or N, are going to tell them you got to go around the long way. Okay? Now I only see one semicircle here, right? C to V. So you could go around this way, or you could go around this way. It's the same thing. But there are some other major arcs we could name. Right? What if I said, you know what? Go from V around to C, and then keep on trucking until you get to L. Right? V, C, L. If you want to find a major arc, all you really have to do, clean this up a little bit, is pick 2 points that are close to each other, right? Watch me find a major arc, like no bigs. I'm going to say J and N, right? Okay, if I just wrote JN, that's a minor arc. That's from here to here. Right? If I want you to go around the long way, all I have to do is still write my J and my N, but I need to put a point. I need to put a point in there, right? So in other words, don't go from J to N. Go around the long way. So what letter could I put in here? J, C, N would do it. J, L, N would do it. J, V, N would do it, right? Because no matter what, if I put C, L, or V in, they're all letting you know, look, don't go straight from J to N the short way. Go take the long way home. So either make a stop off at C before you go to N, make a stop off at L before you go to N, or make a stop at V before you go to N. It's still going to cause the same path. It's going to cause you to go from J to N but take the long way around. What you don't want to do is use a point S that's like in the middle, right? If you say arc J, S, N, that doesn't make any sense. Arcs stay around the outside. Okay? All right. So, again, remember, because we're going to be using this a lot as we move forward, however big this angle is, that's how big the arc is. So if I say to you, hey, this is a 60-degree angle, this is a 60-degree arc from J to N. And if I say to you, this is a 20-degree angle, which is clearly not accurate, that's a 20-degree arc. We would be able to figure out the other arcs from there. Okay? So that's going to become important to us as we move forward. Not today. Okay, so What you're going to do is you're going to hop into Schoology and you are going to answer some questions about central angles, minor arcs, major arcs, and semicircles. And you're going to do that using this diagram right here. Look at this bad boy. All right, so look, there's a lot going on in this diagram. You have two circles, but in this left-hand circle at center P, look at all these angles. You got a big angle here, you got an angle here, you got an angle here. Okay? All the points along the circle are going to help us to make arcs. Over here, you have an X in the middle. You have an angle, an angle, an angle. You've got arcs all around the outside. So all I'm focused on in this diagram are the central angles, the angles in the center, and the arcs that go with them, right? So if I'm looking at this angle right here, then that's this arc here that goes with it. Right, so all I want you to do in this one, all the questions are going to be about find me a central angle and find me arcs. Okay, major arcs, minor arcs, semicircles. In the next video, we're going to talk about the other kinds of angles we see, the kinds that we see that pop up out here on the surface of the circle, the edge of the circle. Okay, they're not central because they didn't come from the middle, so they're different. Okay, any questions that you have on this, go ahead and put it at the end of the video. And then when you're done here, head over to Schoology to name some major, minor arcs and semicircles. Okay, I'll see you soon.